try to solve a problem that's called wildcard matching. So basically, in this problem, you've been given a string and a pattern, and the idea is to match them with the following condition. If there's a question mark, it matches any single character, and if there's an asterisk, then it can match any sequence of characters, including the empty sequence. So, as an example, AA. So there's no question mark or asterisk. So first A matches to this A, and then the second A doesn't have any matching pattern, so it's going to be false. AA and star. So star can match to any number of sequence. So it matches the first A, it matches the second A, so that's the answer. True. C will match a question mark, B will not match A, so this is false. So this is the general idea. And S can contain only lowercase English characters, and P can contain lowercase English characters, question mark, and star. So let's see how do we solve the problem. So we'll solve in two different ways. One is recursion, and then once we get the recursion done, we can look at the recursive expression and we can solve using dynamic programming. So if you're struggling in dynamic programming, don't worry about it. But we'll see how exactly we can take the recursion and we can apply that to dynamic programming. So the first thing is we need to understand the recursion before we get into the DB. So for understanding the recursion, let's try to see the comparison. So basically, let's say you have a string, so A, B, A, let's say this is the string, and then let's say you have a pattern star, A, star, let's say this is a question mark, it's a pattern. So if you see that star matches A, star can match A, but star can also be an empty string or no character match at all. So you can continue matching star with empty A, B, A, and then you figure out, no, I should not have matched to all because it just doesn't match. It doesn't require to be matched to anything beyond empty. So that's kind of thing we need to figure out in the recursion, that okay, when we match the asterisk, we see that okay, let's not consider asterisk to be matching to anything, as well as we consider it's to be matching with one of the characters. That's one thing, one column. So when we have that figured out, we can go to the next one. A will match with A, and then there is another asterisk here. So in this case, asterisk is going to match with B, but just like we talked earlier, that we'll have to think about, it may match with this or it may not match with this. So we have to think about like you will consider asterisk to match with B, or you may not consider asterisk to be matching with anything. So you just move forward to pattern. So we need to consider both scenarios. Now A is going to be matching to the question mark. So this is an easy thing, because if you see a question mark in the pattern, it may just move forward, assuming it's a true condition, right? So now let me get deeper into the asterisk, because that seems to be the trickiest part. So let's say I have a pattern and I find an asterisk, and I'm comparing with, let's say, a character A. So this is the S. So when I see this, when I'm comparing this and this, I may want to think, okay, what if I consider this to be an empty one? When I say empty one, asterisk is just being ignored. So if this is index J, and I'm using index I and J because S is before and P is after in the question. So I is for string and J is for pattern. So it means that, okay, let's just ignore the pattern. So it means that we're going to be considering I, and then you will be doing ij plus 1. So basically what you do is you say, okay, take the character of the string and just move to the next character in the pattern. It means you're just saying, okay, star matches to an empty string, but you need to consider the second aspect as well, which is, okay, now consider that the that you are matching that star with the given character A, for example. So you'll say I plus 1, and then, sorry, so you'll say I plus 1 j. Yeah, this is right, because I plus 1 means that you go to the next character, anything after A. Let's say if there was a B, because now star matched A, star will continue to match to the next one if needed. So as you can see, the star can match with multiple characters, 1, 2, 3, 4. So you're not really required to run a for loop to match anything here, because if you look at that, every time you're going in the recursion, you are branching out two things, whether it's matching, whether it's not matching, whether it's matching. So even this is going to be branched out in the next stack, where you'll be creating two versions of it, where this I, the next I where I'm going to, is going to be deciding whether it should continue with I j plus 2, right, versus I plus 1 j plus 1. So essentially it's just going to be creating a recursive chain where it's going to figure out, okay, star, if it matches to A, let's say star matches to AB, star matches to ABC, like that. And then the second one would be star not matching to A. So you just move to, let's say there was a B here, so you're going to compare B with this. So I hope you get the idea about that. Now let me come back to this recursive code here. So I have a helper function. Some of the boundary conditions that we want to check is, for example, they both finish at the same time. Let's say pattern finishes first. So if the pattern finishes first, then certainly you have some string left. And if there was no string left, it would be true, right? So it means this is a false condition. Now let's say the string finishes first. In this case, you might have just a star there. So this is a check we've, you just want to make sure that you look for the asterisk. String has finished and you have just a star, so you can take a look at it. So if you don't find the star, then of course it's going to be false. This is, I added some optimization, which is a top-down memoization. So even it just makes it like we memoize the results and just makes it optimal so that we can submit it. And then here's the main gist of it. So if you compare, if you find the characters are equal, or if you find a question mark, you can go to the next stack. I hope this makes sense, because we're saying essentially it's fine, we can move to the next one. Now when this is that, then this is when we start branching out. So we say, okay, I j plus 1, it means that I is your character, and you're moving to the next pattern. It means that you're saying, okay, a star matches to nothing, so it's an empty one, so just move. Or you're saying, okay, star match to something, now go to the next character. So we take care of both scenarios, and it's just going to go deep down in the stack, and it's going to compare, like one of the paths will compare with the entire string if needed. So that's about it for recursive. Now once I figured out this is the recursive pattern, it might be easy for me to leverage that in dynamic programming. So in dynamic programming, it's like you build an incremental solution and then you go to the next step. So basically at any stage you're going to be looking at what you have built previously. So typically in dynamic programming, it's going to be, you always be looking at -1. Like for example, if you're at I, then I minus 1, j minus 1 result. So we have to kind of think of this recursion in terms of what happened previously, not what's going to happen in future. So for example, just recursion might be I minus 1, j minus 1, and I j minus 1 and I minus 1j, because you're building the results on the top of what you have done before. So that's exactly what we do in dynamic programming. Now before we get into the dynamic programming, I just wanted to mention that. So let's comment this part out, because this is the recursion based implementation. So we and also in dynamic programming, you think about S&P. So we would include, so the DP array is typically +1 +1, because we want to add empty character at 0th position in the DP so that we can start building the result. And that's going to be used, like I mentioned, recursive is -1 because you're starting from the 0th index and then you're going to be going incrementally, and you always look back at the previous result. So you have to build something at 0th. So you cannot build anything at 0 unless you kind of put an empty string and you kind of have some assumptions there. So what we do is we plus 1, and then so basically DP array. So the way it's going to look is the first index is S length and P length. So I think you have seen this a lot of times. Let's take a look at a pattern. Let's say this pattern, right? So star A star, and then this is question mark. So this is the pattern. Now there's an empty one here at the 0th index, and then there's an empty string here, A B A. So this is the DP array we are creating here. And then now we already know this is going to be true. Pattern is this pattern, and this is S. This makes sense to have it true by default because, you know, empty string and empty pattern. Now remember, when you're comparing an empty string with a pattern, this is going to be true here because this matches. And then what you see here is another, what do you see here? This is A, right? So will A match to this empty? Of course, false. Now once this gets false, even if you have a star, it's not going to be true anymore, because you just remember what you're looking at is, if you're at here, then you're comparing a pattern which is empty star A star, and you're comparing it with empty string. So of course this doesn't match. So the code for that is, if you keep on continuing seeing the star true, as soon as you don't see it anymore, you break, and you know the default value is going to be false. So that takes care of that part. So basically what we want to do is we want to build the first row and the first column so that when we do -1 for I and j, we know what's going on. So we've built this, and this is, we don't need to build anything right now because by default it's set to false. And why is it set to false? Because empty pattern would not match to anything except the empty string. So this we already set to true, so everything is false. Now if you look at that, this matrix has been populated in a way that anytime you do a -1, it's just going to work. Now let's come back to the rule. So let's take a look at what we did for when these two match. So we'll simulate the same condition. When this matches to this or this, then we're saying helper I minus I plus 1j. So since we're looking the other way around, bottom up, we'll say I minus 1, j minus 1. So if you look at what we have done, if this, then we say ij, I minus 1, j minus 1. So essentially the idea is that what you have previously will just continue doing it. If it was true, then it's true case, then we'll just say, okay, true, true, true. If it's a false, then we'll continue saying that. Now for star, say I j plus 1, I plus 1j. So we'll say I j minus 1, I minus 1j. This is precisely what we're doing here. And if you think about it, that does make sense, because what's happening is you're looking in this direction, right? So you're comparing string empty and A, empty and A, and the pattern is empty and star, right? So this would be true if the previous one was true, right? Same here. Let's say if you're here and then you're comparing empty star A with empty A, empty A. So if this was true, it's going to be true. So basically there are two conditions. It's checking I minus 1 or it's checking the other one, j minus 1. I j minus 1. So you get the idea. Basically once you get the recursion, it should be fairly straightforward to do that. So with that, we can try to submit this, and I'm guessing I submitted it a while ago, and this is, yep. So all right, thank you very much.